All right, we talked about prescriptive analytics and the keywords that we had. We solved the phone problem, we solved the diet problem. Some more questions for you. So I want to read this now. This is a very interesting problem. It's for recruitment of nurses for a hospital. And it needs to satisfy this. Again, every problem is gonna have a different structure. And I wanna see if you can model this. So what is the first thing you should think about? What is the decision variable? Basically, how will I present the solution? A hospital needs to schedule nurses so that it can satisfy the projected weekly demand. This table shows the projected number of nurses required for each day of a week, and that's going to be recurring. If a nurse is assigned to a day, basically, she or he needs to work for 3 consecutive days. For example, if they are assigned to work on Monday, they're going to be working Monday, Tuesday, Wednesday. What is the minimum number of nurses that the hospital needs to hire to satisfy demand? How does, if we try to do what we just did with the diet and the phones, like create a table to try different answers, what do you think, how do you think that table will look like? Like, what will be the solutions for this? How do we represent the solution? Or what is it that if we say it, it will be an answer for this problem? We don't care if it's feasible, infeasible, or whatever. What is a answer for this? For the diet problem, the answer wasn't how many carbohydrates to take. The answer was how many serving of each food to take. The previous problem, the solution was how many of each model to produce, to manufacture. Here, what do you think would be the solution?
Number of nurses to hire.
How many to hire, right? But let's say my answer is 20. How do you check to see if it's feasible or not? If I just say 20. 20. Like, how do you compare? How do you go about comparing a solution that's just 20 versus 21 and so forth?
Need to establish your decision variables.
Yeah, like decision variables will be what? Like X1, what is X1 or X2 or whatever?
So the thing is the variable time. So if she work on today, tomorrow she has to work too, and the day after.
If she is assigned
Yeah,
to Monday,
yeah,
she
that,
needs to work Tuesday and Wednesday also.
so that logic is hard to put in a number.
How would you try it? Like let's say you want to hire them and you're trying to find a minimum number of nurses to hire. Let's say I say hire 15. How do you check 15? You want to see if 15 is enough, right? because you have the demand here. You need 5 on Monday, 6 on Tuesday. How do you check 15?
The number of shifts added
Mhm.
should be,
So if I add those 5 plus 6 plus 7, which is 18 plus 6, 24, plus 15, 39, 49, 64.
divided by.
Divided by 3, 64 divided by 3 will be 21.3. So, but how do you check to see if 21.3 is enough? That I am making a intentional mistake when I say just hire. So it seems like if I tell you just hire 15, 15 is not a good way of expressing the solution. Because you cannot check to see if it satisfies this schedule, right? What is another way of saying this is the solution? So just saying that hire 15 is not the correct way. Like I'm trying to find X. Like what I was telling you is X number of nurses to hire. There is no way for me to check that. Like if you were to check, let's say I said 20, you wanna check to see if 20 is enough or not, what would you do?
Wait, that should be in hours, right?
Mhm.
Measure in hours.
No hours, just like,
Oh, all days, yeah.
how about this? X1. Number of nurses. Assigned to Monday.
Sense.
Then X2. Now, how do you check this stuff? Okay, do you agree that? So I can give you the solution. Hire this many for Monday. Hire this many who will start on Monday. Hire this many whose start day is Monday. Hire this many, like 2 whose start day is Tuesday. 5 whose start day is on Wednesday, and so forth. That's the solution. And some of those is basically total number of nurses that I will be hiring. So it will be minimize will be v equals x1 plus x2 plus all right. So if I ask the computer to solve this, obviously it says just hire minus infinity. Doesn't make sense. So I add this constraint that says x1 x 7 should be or I can write that as they belong to this set. 0, 1, 2. Okay. Now the answer is 0. Which doesn't satisfy the demand. So what are my constraints here? Remember, the diet would be 0. Don't buy anything to minimize your cost here. But what made it positive was, hey, you need to satisfy calories. Here is the same thing. You need to hire, it says hire 0, but I'm like, hey, you need to satisfy the demand that we have for these nurses. How do I express that demand? Demands are given here, right? But how do I write that? Should I just say X1? Hire 5 on Monday, 1 on Tuesday. Yeah, that sounds like a good solution, but let's see if that's good. I'll test your solution soon. How about this? X1, because X1 is what? Number of nurses assigned to Monday. X1 greater than or equal to 5. And then X2, is this a good way? Greater than 6 and so forth. It's not good. Why is that? It says on Monday I need 5 people. Right?
And you have 10 not working, right?
Hmm?
And the rest is not working. You have 5 people.
So I hired, it says Monday needs 5 people. And I'm saying, make sure the number of people you hire who are supposed to start on Monday is greater than 5. And then I'm saying, make sure your number of people you hire who will start on Tuesday are greater than or equal to 6. But what's the problem with that constraint? Yeah.
Doesn't account for the consecutive days.
Yeah, because if these guys started on Monday, they already are on Tuesday. And they already will be on Wednesday. So should I make it like this? Greater than or equal to 1?
Minus the previous.
Because I know X1 plus 1. Let's have a different approach. Who is working on Monday? People who hired for Monday to start on Monday. But also people who were hired to start on Saturday and Sunday. All of those people will be there on Monday. Does it make sense? So I can say X6 Saturday plus X7 Sunday plus people who were hired for Monday, some of those should be greater than or equal to 5. Same thing for Tuesday. This is for Monday. Who works on Tuesday?
X1 and X7.
People who start on Sunday, X7 plus X1 Monday plus. Noah, you can see the answer now. And then Wednesday, Thursday, Friday. X for Wednesday, Monday, Tuesday. Boring, but next to. X. Make sure we're not in the complete. Oh, we need 15 people on. Yeah, weekend, more injuries, right? Wonder faster. This is Sunday, which has to be 15. All right,
The Tuesday line should be 6.
Tuesday, 6. 6, 7, 6, yeah. Okay, now this is a complete model. Minimize, subject to the constraints, and so forth. All right, let's take a break now. Let's just start at 20 after 7, 7:20, and then we'll continue. We'll check the solution that Noah gave us, see if it function, if it works. Okay, to check, let me actually quickly. Yeah, okay. Let's look at a few examples here. So we have 7 variables. X1, X2, 3, 4, 5, 6, 7. And then status and objective function value. Solution 1, solution 2, and so on. Let me just try a few things. So I think one of the solutions that you shared was No's intuitive answer, which is fire 5 here, 1, 1, and then go with that. So if I do that, fire 5 on Monday, then you will look 1 here and 1 here. That's obviously feasible. But then you would have to have, let's say I go by this. This checks for the first constraint, one for the is this feasible? I checked the last constraint, 111, not feasible. So how about this? I hire 1, 5 here, checks. This check, this check. Here, I only have 2 from the last 2 days. I have 2 and I need 6, so I hire 4 here. Then I go look at Thursday, sorry, Friday. I have 5 from before. I need 15, so I hire 10 here. And if I hire 10, I have 14 here, 1 extra, so don't hire anyone here. And then for Sunday, I have 10, and I probably need 5 here. So that is feasible. Feasible. And the status is, these are total number of people I hired. 7, 11, 21, 26. Would there be a better solution? So a problem like this is very easy to find a feasible solution. Like if you were to find the fastest solution that's also feasible, what would you do? In this problem, if I ask you, give me one feasible solution without thinking, and who wins? The one who gives me the fastest answer. What is the feasible solution? Like ignore this one. Other than that, what would you do?
Anything more than 15 or x is more than 15.
Hmm?
Anything more than 15 would work.
Anything more than 15 for which variable?
But, x1
Like, let me ask you this
and x.
question. Whoever gives me a feasible solution for this problem, first, they win. They win a prize. What is something you can instantly come up with?
X order 15.
Makes all of them a very large number, like
Yeah.
200. 200 checks, if they are all 200, all of them will be checked. It's just not a good solution, it's a terrible solution, right?
Yeah.
So because you are also thinking about optimality,
Oh,
but if you're only thinking about feasible, just go as high as much high as you want, right? So this is 100, 100. This is feasible. Objective function though is 700. You have to hire 700 people. It's feasible, but is it efficient? No, because you can say you already have a feasible solution that's 26. So anything that's above that, you discard. But we'll look at this later to see what is the optimal solution. But it's good that we were able to find one feasible solution. Or any questions so far? This was a tricky question, basically. But so each one is gonna be new, something you haven't seen before. Next one is probably much easier, but let's see what it is. Investment problem. You might be interested in it. An investment company currently has $2 million fund to invest in 4 possible categories: bonds, options, stocks, and savings. The company would like to keep the total risk associated with investment less than 6%. So the risk of each choice is also given to you. The average risk is calculated by dividing the expected risk over the total money invested, not including the saving account. Yeah. So
Oh, that's $1 million question right there.
the average risk, the company would like to keep the total risk associated with the total money invested to, I'll figure that out. I think the wording is difficult here. This table shows you expected earnings of each option in percentages, how much the company should invest in each category to maximize the earning. So all I want you to do now is just to come up with decision variables, objective function, constraints. And the first step is always decision variables. And decision variables is what will contain the solution. While you're thinking, let me check something here.
For 2 million,
What is it?
how much the country?
$2 million.
2 million.
The decision variable basically tells you what to do. So here, if you had a way of solving this, how would you express what to do?
So risk is the number of losing.
Risk is, the average risk is defined as they want the average risk to be less than or equal to 6%. And then the average risk is multiplied like, multiply the percentage of risk by the amount you invest, and then divided by, sum them up, divided by total amount you risk. Let's say you only invest in options. It's 8 times the amount you invest in options divided by total amount you invest. Do you have the decision variables? You know what they should be? So the decision variable tells you what to do. Look, what is the decision variable here? X1. It tells you how many to hire for each day, right? The decision variable here, the previous last week's, here tells you how much to manufacture of each. Or here it tells you how many servings to purchase of each item. So what would it be here in this case?
The amount of bonds and then the amount of option.
How much? Yeah, amount of bonds, options, stocks, saving, amount. So what do you think will be the variables? Like how should I write the variables? X1, X2.
So the first one would be X1 plus X4 gonna be $2 million in total.
So X1 is what though? What is the meaning of X1? The meaning of X1 here was number of nurses assigned to Monday, hired for Monday, hired to start on Monday. More nurses. Here, it was X1, sorry. The previous ones was number of phones model A to produce. What is the definition of X1?
Dollars amount of option
Amount,
of options.
amount invested in options. Amount of money invested in bonds and X3 is stocks, amount invested in stocks, and then X4 is amount of money invested in saving. If that's the case, how do I write my objective function as a function of these variables? What is the objective function?
D max.
Before that, I should write another word. How much the company should invest in each category? Invest X1 in options, X2 in bonds, X3 in stocks, and we don't know what those are yet. The objective is what? Maximize the earning. So maximize earning. What is earning? Z equals 10 times, that's the percentage, right? Basically 1.1 X1. Does that make sense? Plus, because 10% added to it. 1.15 X2 plus 1.2 X3 plus saving gives you just 2%. So 1.02 X4. Okay, and then if I have the computer solve it, I'm gonna add the constraint that says X1, X2, X3, X4 are all greater or equal to 0. So if I ask the computer to solve it, what is the answer so far? Infinite, because it says just do infinite in each. There is a constraint that says you cannot invest infinitely. What is that constraint? One of them is we don't have infinite amount of money, right? So that constraint says limited budget, which says, how do I write that? Yeah, some of those excess, some of the amounts I invest should be less than 2 million. So X1 plus X2 plus X3 plus X4 less than or equal to 2 million. Then what do you think it will be like at this point. What do you think the problem will do, the algorithm will do? If you ask the algorithm to solve it. If it's set up like this.
It will pick the highest,
It will
One
pick
of the
the
highest
stock, it will pick the choice that has the highest earning, which is the stocks, 1.2, and it will invest all of the 2 million in that. Does that make sense? But what is the problem with that? It also has high risk, 10% risk. It says total risk should be less than 6%. How do I write the total risk? So this investment has or average risk. Less than 6%. If I invest everything in the stocks, what will be the average risk? It will be 10%. Right? It will be 10 times 10x1 divided, so plus, sorry, 8x1 plus 5x2 plus 10x3 plus 0. I can ignore it, but I'll show you why. X4, that's the total amount. If I divide that by x1 plus less than or equal to 6. Does it make sense? For example, if I invest everything in, let's say $2 million invested in the stocks, all of it. So this is 0 because x1 is 0, x2 is 0, that's 0. 10 times 2 million plus 0 divided by 0, 0, 2 million. So those 2 millions will cancel out, it will be just 10. Less than or equal to 6, no, so it, that is infeasible. So we'll try to use another combination. It's like a weighted sum. Average risk, basically. So we don't want to write constraints like this. I'm gonna multiply both sides of this inequality by this term. If I do that, the denominator will be canceled here. So basically, let me do this. I'm gonna multiply both sides. I'm gonna rewrite it. Multiply both sides by that term. This one will be canceled. It goes away. And this side will be multiplied by term. Then if I further simplify it, I'll have 2x1 minus 1x2 plus 4x3 plus, sorry, minus 6x. That should be less than or equal to 0. So these are just different forms of the same constraint. So if I simplify it as just one model, I can write it like this. Maximize the model basically is that it's uh, for the previous problem, the computer doesn't understand text, so we want to remove those. This is the final model. Any questions about this or in general so far? So how would you go about finding the optimal solution if you didn't have any solution methods? With this. This is your model. Status Z. Solution one. So I already gave you one solution. I said invest everything in the stocks, 2 million in stocks. The problem was that with that was it was infeasible due to constraint one, constraint two. Why? Because 2 million, so 0 minus 0 plus 4 times 2 million, 8 million is not less than or equal to 0. It violates this constraint. It's feasible. It's infeasible. Can you give me another one that improves that? We can add some. So this 2 million here, are you following? So I tried this answer, 0, 0, 2 million, 0. I plugged it in, it checked here. But here it failed because 0 plus 0 plus 4 times 2 million, 8 million is not less than or equal to 0. So next solution I'm going to try, I'm going to add some that basically makes this expression, this term, be less than or equal to 0, becomes negative. So I need to add some to x2 and x4. Does it make sense? I'm gonna add, let's say 1 million to x2, keep that 0, or 500 here. So I have 1 million and maybe 500 here. And then I'll invest 1 million. Let's check that answer. Some of these is 2 million. That checks. How about risk? 500 times minus 1, that's minus 500,000, plus 4 million minus 3 million. That makes it feasible, right? So the sum becomes 0. What will be the objective function value? 0 plus 1.15 times 500,000 plus 1,200,000 plus, oh, that's actually 500,000. So it becomes a reasonable number. And I claim that this is actually the optimal solution. I claim it. I suspect, sorry, I don't claim, I suspect it's optimal solution. But I'll tell you why I think so later. Any questions so far? Okay, let's look at another one and then I'll basically I'll switch to another type of problem. So this one is for you. This one is a little different. As you see, every new problem we encounter is a little different. So 3 shuttle companies are hired by the city of Pasadena to provide shuttle services for a public event in the city convention center. Table 1.5, this table shows the transportation cost per passenger by each company from 3 stations determined by, basically, this is how many people you have in each station, in the last row. 35 at station 1, 10 at station 2, 10 at station 3. And these companies can take these people from this station. This is how many people company A can take, how many people company B and C can take. And this is their cost, basically. It's $15 per passenger, this one is $14 per passenger, and so forth. So it wants you to determine the schedule of shuttles so that the total transportation cost is minimized. So any problem like this, or every problem that we encounter, the most critical part, the most difficult part is the first step, which is what should be the decision value in terms of modeling. What do you think should be the decision variable here? First, don't think about X, Y, and variables. First, think about how you would explain a solution for this problem. How would you go about explaining a random solution? Let's say your boss asks you, hey, we have these companies and these many people waiting at the stations. Go figure it out. Like, come up with a schedule. What is that schedule? Like, when you give them the answer or the solution, what's in it? How do you explain it?
Would it be how many people we can move at the lowest cost? Transportation cost?
You're supposed to move all of them. So how many people you can move? You have to move all of this. 35, 10, 10. You have to move all of them. Like, there is no, if you say minimum cost, don't move any of them. That's 0 cost, right? It's a requirement, which means it's a constraint that you have to move all of these people. If you were to ask somebody who is an expert in operations research to solve this problem, or what is the problem? That's a better question. What is the problem? What is something that we don't know? If we knew it, the problem would be solved. There would be nothing to solve. What is it that we don't know how to do it? There are many ways to do it. Number of people, we have to move, that's something we know. We know that all of these people, we have to move them to the convention center. 35 people are waiting in station 1, 10 at station 2, 10 at station 3, and we need to move all of them to the convention center. What is it that's unknown?
The convention center supply, I guess, or
Let's say you know exactly where it is, the convention center.
Like how to allocate people to different companies at each station.
Yeah, that's a good problem. Because I don't know how many should go with company A, how many should go with company B, right? If I knew that, there would be no problem. I need those 35 people in the station 1 to move to the convention center, but I don't know how many of them should go with company A, who has a capacity of 30. Obviously, A cannot take all of them. I don't know how many should go with A, how many with B, how many with C. Total demand is 55, 35 plus 10 plus 10. Total capacity is 50, 74, but we don't know. We have enough capacity to take them all, but none of those companies single-handedly can take all of them. I need to distribute those passengers between those companies, and I don't know how to do that. And because there are many ways I can do that, it's an optimization problem. Why? There are many ways to do that. 35 people in station 1, 30 of them can go with company A, 5 of them can go with company B. Another way, 30 of them go with company B, the other 5 go with company C. Right there. I have more than one answer. It's an optimization problem. Make sense? So from what we discussed, how would you determine the decision variable? I know it's 8 p.m. You've had a long day, but what do you think?
So number of people allocated to company A at station 1 is going to be a separate parameter from basically the number of people allocated to company.
So yeah, you're saying X1 is number of people allocated from a station 1 to company A. X2 is number of people allocated from a station 1 to company B, and so forth, right?
Yes.
Yeah, that's a good way of, because once we know that, we know the answer.
And then the capacity and demand are just constraints on,
Those will show up in the constraints when we make the model. We will say to the model, the computer, hey, when you're doing these allocations, make sure total number of people company A is gonna take is not more than 30, because they only have a capacity of 30. Instead of company A, B, and C, you can think of like a friend who says, I can take 30 of them. Like their car or van, they have like 2 vans, I don't know, 10 vans. No, what's that? 3 vans. So I'm gonna write X1 equals, or is defined as number of people taken from station 1 by company A. X2 number of people taken from station 1 by company A. And so forth. But there is a better way of writing these notations. Instead of X1, to make it easier to understand, instead of X1, I'm gonna write X1, 1. It's number of people taken from station 1 by company A or company 1. Then I have X1, 2, number of people, station 1, company B, or company 2. And I can summarize it because there are 3 and 3, I have to write 9 of those. So I simplify it, I will say X ij is defined as number of people taken from the station I by company J. Does that make sense? Instead of writing all 9 of them, I just summarize it like that. Now, if that's the case, how do I write the objective function? Objective function, is it minimize or maximize? Because these are costs, we need to minimize. Also, it says transportation costs minimize. Minimize cost. What is the cost? How do I write the cost? To what variable does this $15 apply?
That's 1, 1.
X11. It applies to people taken from station 1. So 15 X11. Company, station 1, company. Plus, tell me the rest. Plus 14, what should I write? X
1, 2.
1, 2, because the first one is a station, the second one is company. I'm talking about this one. Plus 13 X 1, 3. And then that continues all the way to the last, to this one, last row, or last column. Let me write the last 3. Then X 3, 3. Again, if I ask the computer to solve it, it's going to be minus infinity, but I'm going to write a constraint that says X ij belongs to or is in this set. And then I'm going to add a new notation for you here. It says for all, this notation is for all I and j. It says for all values of I and j, 1, 2, 3, 1, 2, 3, for all of them, xij equals, it has to be an integer and positive. That's how you read that notation, for all. We'll have some of those. So if I solve it now, the answer is going to be 0. What is something that I add? What constraints do I have, basically? What is one limitation that I have which forces this problem to be non-zero, the objective function to be non-zero?
The capacity and the demand.
So it's first the demand, because if I add the capacity, I mean, the order doesn't matter here, but company A has a capacity. Company A, 1, but I prefer to add demand first because capacity constraints are gonna be in the form of less than or equal to, for example, 30. Do you agree? It says the number of people company A which we called 1, X should be less than or equal to 30. So if I write that, there are gonna be a bunch of variables here. Some of those should be less than or equal to 30. The solution is still 0, right? So I usually start with demand. Constraint 1, demand. The first constraint in demand is all people in a station 1 should be taken, right? Which means some of the people company A, B, and C take from station 1 should be greater than or equal to 35 or equal to 35. But I usually prefer to write them demand as greater than or equal to, capacity less than or equal to. So what should I write here? Which variables should I write here? Or before I do that, now that I define my variables like that, let's see how the solution looks. The solution looks something like that. Let me Station 1, station 2, station 3, company A, company B, company C. The list of my variables are these. X11. What is this? X 1, 2, because the first index is the station. Then here I have X13. Paste. Two, 2, 3. Now, the first solution is these x's are gonna have variables. So, for example, one solution is 20 and 10 and 5. Out of this 35, 20 go with company A, 10 go by company B, and 5 with C. And here it's gonna be 5, for example, 5. It's just a random solution I'm generating here. 5 here, 0, and then 5 and 0. All right, so all people in a station 1 should be taken. Which variables show the number of people taken from station 1? These, right? Which are x11, x12, x13. So I'm gonna write it as x11 plus x12 plus x13. Some of those should be greater than or equal to 35. And it checks here. It is exactly 35. And then I need to add another one for the station 2, another one for the station 3. I'm gonna quickly do that. For station 2, it has to be 10. 3, it has to be 10, except I need to change this indices. 2, 2. All right. If I give the computer this problem, what do you think? What problem do you think will happen? It says x11 plus x12 plus x13 should be greater than 35, and these are the costs. If I don't add the capacity, what will happen?
We'll put everybody in one company.
Well, basically for each one, you see like for x11, for here, it tries to see which one is the cheapest. It fills that 35 with the cheapest options by looking at the costs here, or the costs here. For example, here it looks and says, oh, the station 1, company C is the cheapest. So add all 35 to company C. So this will be 35, these two will be 0. And then what if company C is the cheapest for all of them, which is the case here too. At station 3, give all 10 to the cheapest, which is company C, $10. So x33 is also 10. But you assign 10 and 35, 45 people to company C. Company C has only capacity of 24, so you cannot give all of them to that. So that's why we need to add another constraint for each company. So the actual capacity, basically, capacity, and here we have the demand. The demand here is sum of these three, which should be greater than or equal to 35. Basically, this goes here. It says these three should be less than or equal to 35. This goes here. Some of these should be greater than demand. And then for capacity, you add up these three. Some of those three should be less than or equal to the capacity. Therefore, x11 plus x21 plus x31 should be less than or equal to 30. And then we add another one for station B and another one for station C. Then x12, x22, x32, capacity, which is 24, 20, and then 30. All right, now the model is designed well. This is a good model now. That's the objective function subject to these constraints. Any questions so far? All good? Is there any part that, so this solution, does it check? Is this feasible or infeasible? Feasible. Feasible? Some of these is 35, some of these is 10, checks, some of these is 10. How about capacity? This is 30, checks, 15 is below 20, checks, 10 below 24, checks. So this is a feasible solution. What is the objective function? You multiply this matrix by the matrix of cost, you get a value. This is feasible, and just like that, we continue all of this. Just to give you a heads up, next week we're going to have a, I mean, probably I meant to give you a homework for this at the end of for next week, but doesn't seem like I'll be able to finish the graphical method. This graphical method is a new story. Needs more time. I will do that next week. So your first homework will be assigned next week. So for the rest of the session, I want to see if you had the chance to think about what you can optimize at work or places that you like. Was there anything that you thought would be a good choice for optimization at work or anywhere else? On campus, in the city, anywhere, anyone? And it's this part of the class that we have where I go back and forth with you with them for choosing a problem is also very important. Because you need to know where is the right application for mathematical modeling and optimization. And these examples, this back and forth, will help us a lot in doing that. So anyone, any experience, anything that you observe that you think would be a good candidate? You can share it, whatever you think. That, like, think about your workplace, right? You have probably observed inefficiencies or things that are done a certain way, you think they can be done better. What are those? And you can just share those with us. If it's a good optimization problem, great, that can be your project. If it's not, again, great, because we will discuss why it's not a good choice. So what is something that you can think of? Think for a few minutes and then share with me. Where do you work again, Rashid?
I work at a aerospace company in Burbank.
What is it?
Aerospace.
Aerospace.
We do ducting.
Manufacturing?
Manufacturing.
And, okay, I can think of a few problems there. What are the orders? Like, what do they make? The specific parts?
So we make ducting. for their
Ducting, you told me
engine.
about that.
So our process involves at a detail level, forming, fabrication, machining, and then at an assembly level, fitting, welding. It could be.
Is it made to order or just like make to store,
Made to order?
made to order? So they have different demands? from different aerospace companies.
Mhm.
They fulfill those. Do you, like everyone can contribute? Where do you think? What is something that you think can be done in another way? And I'm talking about something very specific, not something general, like management can do better. Like something very specific. Like they receive orders and each order requires a different set of machines, right? And they're gonna take a different amount of time on each machine. And they probably have more than one order, so they have to schedule them. Like company A has given me an order, 1,000 of these parts. Company B has given me an order, 2,000 of these parts. And they probably both want it first, they have a deadline. So should I process company A first, then B, or B first, then A? That's, there are two ways I can do it, so that's an optimization problem. Now make it 10 companies, and each company has orders for 5 different products, it becomes way more complex. Because you don't wanna say no to any of them. It's money. And then, but you won't be able to, given that you have a limited production capacity, cannot do all of them on time. Or as soon as they want. So you're gonna face some delay or, what's that? Due date issues. Now. There is a trade-off. That's also a good sign that there is an optimization problem. There's a trade-off. If I go with the more expensive ones, I make more money, but there is a chance I lose my customers how should I balance that? So that's one thing. Or another thing in a manufacturing plant is they probably need, do they work shifts or 24/7? How do they work?
Shifts. There's
Two
a-
shifts?
Yeah. There's a main shift and then like a smaller second shift.
Is it like 9 to 5 and then 6 to
It's 5 to 3:30 and then 3:30 to like 2-ish.
5 AM to 3:30 PM? And then what's the next one?
3:30 until 2-ish.
Oh, okay. So pretty much they make work all day. And then weekends too?
Saturdays, maybe like end month Saturdays can be mandatory
Uh-huh,
for the production people
yeah.
and then other Saturdays.
For a staff is, yeah. So. Another thing, just like the scheduling of the nurses. There, I also see a potential optimization problem, which is crew scheduling. Who should go to work which days? And which shifts? And sometimes people can do multiple things. Like, they may have one easy shift, one difficult, alternate. But then you need a certain amount of people with certain skills to be present at its shift, to be able to operate the machines. So how you have 20 people, person A, B, C, D, all the way. Person 1 to person 20, and then you have this demand in your shifts. How do I assign them to those shifts? That's an optimization problem. So these are all examples, things like that.